But the unit circle makes things much easier to remember. Much easier. But there's a lot going on in it. Okay? It starts out with what we talked about here. There's, like I said, there's a lot going on. So it's very important that you can kind of section it off, that you see patterns. Okay, patterns are very important in the unit circle. So the unit circle is where we start to put these sine, cosine, and tangent functions in the coordinate grid. Definitely need some practice on your eyes. Look at that. Wish I had control me up here. Circle. See if I can figure this out. Oh, yeah, didn't I? Yeah. That's how I try to use it, so. That doesn't make sense.
The one point you hold is where it's at least 1 point of the circle.
I get it.
Yeah.
I get it. Usually you put the center and you cross the radius out and go like this. Okay, so I do this. That's okay, I'm just going to draw my own lopsided circle. So the circle has a radius of 1. That's what we call the unit circle. The neat thing is, instead of all these sine and cosine ratios that we see from yesterday, let's look at this. What coordinate is that? No, the radius is 1, so it's 1, 0. I just scaled it out. Okay. Anybody tell me what this coordinate is then? 0, 1, and then we have -1, 0, and here. Okay. Again, notice the pattern here that you need to. 0, 1, 0, -1, or 1, 0, -1, 0. Okay. You see some patterns there. The big part of this is placing triangles in here. That's a 45-degree angle. Let's make that 30 or 60. That'll make this 30, right? I already gave you that triangle. This is 1. That means this is 1/2, and this is √3/2, correct? we agree to that. So 30, 60, 90 triangle, if the short side is 1/2, my hypotenuse is twice of it. And we multiply by root 3 to get that side, right? Yay or nay? Hard thoughts. So did you understand this triangle? I took that triangle and transplanted it in. The hypotenuse is the radius of the circle. So what's this corner? Yeah, the x value is 1/2, and the y value is 2/2, right? Yes. Okay, fine. I put on the gas pedal then, and move on. Okay. Look at your papers from yesterday. Anybody tell me what the cosine of 60 degrees is? Holy crap. What's the sine of 60 degrees? Holy crap, look at that. It's a way goes for matching purpose. You betcha. You betcha. This here gives us a cosine value and a sine value for 60 degrees. This is the cosine of 60, and this is the sine of 60. That's what the unit circle is going to start telling us. Is these cosine and sine values. What? Yeah, I want to do another, but I don't want to make it so ugly. Okay, 45 degrees. You good there? Okay, I want to. So, you can see coordinates here, right? What angle measure is this? 0. So what's the cosine of 0? 1. So what's the sine of 0? 0. Right? What's the cosine of 90? 0. And the sine of 90 is 1. See how this is starting to make a pattern here. Cosine, sine. Cosine of 180. Sine of 180. Cosine of 270, sine of 270. If we can build this entire unit circle 30, 45, 60, 90, and then we can go to 120, 135, and 140. And we're going to go all these triangles and all these angle measurements so that you can actually remember them. The 45 degree, 45, 45, 90 triangle. Is a little bit different. It still holds the ratios. It's just the hypotenuse is 1, so it kind of presents itself differently. What is the cosine of 45 degrees?
45,
The x value here, root 2 over 2. What's the sine? 2 over 2. The y value. Ooh, yeah, your brain is fucking out. So cosine 45, sine 45. Kind of making sense? We've done 60, and we've done 45. We can also do 30. You want me to show you 30 degrees? On the board? Yeah. Let's see if it's shaking that. I'm assuming that's all of us. So. Another unit circle. I wish my circle got for us. Right, and we're going to have a 30, 60, 90 triangle. Again, radius is 1. What is the y value here? Yep. And the x? So the cosine of 30 is 3 over 2. The x value, and the y value is cosine 30. 1/2. And see cosine again? Yeah, sine of 30 is 1/2. So, I'm going to give you a handout with all this on it, right, for everything, and you're going to start seeing patterns. So, let me show you a different quadrant. So, what if I wanted to say, look at a 135 degree angle. The reference angle? Yeah. This is where those reference angles start to come into play big time. What's that reference angle? 45. Guess what? Pretty much the same. Okay, we just have a negative x value. Right? So this number is negative root 2 over 2 because it's in the negative x direction. And this is root 2 over 2. Because it's positive y still, correct? Right. So our coordinate you can see how they match. They just have a difference of a negative. The cosine of 135, negative root 2 over 2, and the sine is root 2 over 2. You can do it down here too. Yeah, so here it will be negative root 2 over 2, negative root 2 over 2. Negative and negative, right? And that, what angle would that be? 180 plus 45 is 225. So, you get patterns. Okay. Let me give you that handout. I don't want to, we're not going to draw it on the board because it's an absolute mess, but okay, where did I put it? So this has all of them on it, and it has radians. So if you start to see pies on there, don't pay attention to it right now. Okay, you don't need to worry about pies in the unit circle yet. And the back side is the next chapter. It's just the same picture. So what you need to see are some patterns there. They put this up on the. So yes, you have to memorize this. Yeah, you'll have several quizzes the rest of the year on this. Okay, so it doesn't work. What doesn't work? Oh, never mind. Okay, there's your handout. I want you to notice some patterns. Okay, we have just the angles 30, 45, 60, 90. Okay, notice that it skips 15 and 75. They're not special right triangles, so we don't worry about including it in the unit circle. Okay, but you can count 0, 15, 30, 45, 60, 75, 90. It goes by 15s if you include those numbers. Okay, look at this. 1. Okay. Look at all the fractions. They're all over 2, right? 3, 2, 1. 1, 2, 3. 3, 2, 1. 1, 2, 3. Those are your cosines. Right? Now you have to remember that they're all over 2 and that you have some square roots there, but that pattern holds pretty well. So 3, 2, 1, and you can even hit 0 if you want. So 3, 2, 1, 0, negative 1, negative 2, negative 3, negative 1, negative, etc. Okay? The signs 1, 2, 3, 1, 3, 2, 1, 0, 1, 2, 3, 3, 2, 1, 0. Okay? You have some patterns there to help you. All right? So, tell me, what is the cosine of 210 degrees? Negative root 3 over 2. Okay. What is the sine of 315? 315, negative root 2 over 2. Okay. This can help you immensely in being fast. Right. Again, if you see numbers with pi in it, those are called radians. We'll get to that next chapter. So just worry about the degrees today. Any questions on the unit circle? Okay, let's see if there's anything else. What is the cosine of negative 180? Okay. Zero. Negative 180 is backwards 180 degrees. Cosine is negative 1. Okay. What if I asked you what the sine of negative 135 is? Here. Negative 132. Okay, so if you have a negative angle measure, we're going backwards. Right. So basically 360 minus 135 is 225. That's very good. Counter, okay, clockwise is negative. Counterclockwise is positive. Okay, so keep that in mind. Are you good? So you can handle some problems here? Okay. Let's make sure this, you should be able to do these problems. I just want to make sure you can. Some of the questions you're going to see might say something like, find the value of the 6 trig functions for angle theta in standard position at a point with the given coordinates and on its terminal side. Exactly. Okay. And you can do this, it's just a lot of wordage you haven't seen before. Standard position. So we're at standard position, that means normal position that I showed you. Terminal side is where the angle ends. So it's in quadrant 1. That's a normal. Okay. With coordinates negative, or sorry, let's say 4, 3. That would look like that's what that's saying. It has to be very perfectly descriptive. So, this is 4, correct? and 3 x and y values. What's the hypotenuse? 5? Yeah, I set that up to give Pythagorean triple. If it's not, you can use the Pythagorean theorem to calculate the hypotenuse. Okay? What is the sine of theta? Three over, it's the opposite over hypotenuse, right? 3 over 5. What's the cosine of theta? Huh? What's the cosine of theta? Cosine is ca adjacent over hypotenuse. Anybody want to help out? 4 over 5. Tangent is opposite over adjacent, 3 and 4. You see how you work on those? It's just a different way to throw it at you. Okay? Cool. There we go. Don't worry about the rest of the handout. It actually looks pretty good, but we're just going to skip it. Too much work for us, considering the amount of hard work that you guys have to do. We got 10 minutes or so. Try to get a few problems done.